In this video, I'll show how to solve three equations in three unknowns, x1, x2, and x3. And I'll do it using row operations. As we remember from the earlier videos, what I want to end up with is a system of equations which look like this, in which the coefficients of x1, x2, and x3 are all 0 except here, where I have coefficients of 1. And of course I have the three solutions out here as numbers. So that's how I want this to transform my equations. And that's what we're going to do now. Now I am going to be needing quite a few row operations. So in order to simplify the process a little bit, I'd like to discard the x1s and x2s and x3s. So what I'll do is I'll just remove them and keep my rows and columns straight, so I'll be able to reconstruct the equations at any time. So now I've discarded the x1s, x2, and x3s, and what I'm left with is this table of numbers, which still represents my three equations. And what I want to end up with is now a table that looks like this. And then I'll have my solutions for x1 is A, x2 is B, and x3 is C. So I want to end up with a table with all zeros except in the diagonal. So the first thing I would want to do is to divide this first row here by 2 in order to get me a 1 here. So let's do that. So we divide this row by 2, and what that gets us is a system of equations which is equivalent, which looks like this. So now I have divided this equation by 2 and thus obtained an equivalent. This sign means equivalent, an equivalent system of equations here. So the next step is now to multiply this row by some number and then subtract the thus transformed row from this row down here in order to provide a 0 here in the first column. And in this case there's a 1 here and a 1 here, so all I need to do is subtract this first equation or row from this second equation or row. So what I get when I do that is an equivalent system of equations which looks like this. And you can see I've modified this second row here by subtracting the first row from it. And this has given me what I wanted. That is a 0 right here. So the next step is to provide a 1 here, and of course I'll do that by dividing this second row by -4, like that, and that gives me this system of equations in which there's a 1 here in the diagonal. Now my next object is to create a 0 here in the third row by subtracting this or adding this equation to the third equation down here, possibly multiplying by some number first, but in this case there's a 1 here and a -1 here, so all I need to do is actually just add this row to this row down here, and that will give me the 0 I want in the first column. Like that. And now I have my 0 here. So all I did was I added this first equation to the third equation, and this is what I obtained. Now I want to provide another 0 here. I can't do that with the first equation because that would mess up my 0 over here, but I can multiply the second equation by some clever number in order to transform it in a way that would make it possible to make this 5 disappear. So obviously what I need to do is to I need to multiply this by 5, because then I'll obtain a 5 here that I can then subtract from this 5 down here and provide another 0. So what I do is I multiply this equation by 5 and then subtract it from this equation. And then I obtain this system of equations. And now I have 2 zeros and I would like to provide a 1 here. So obviously I just multiply by the inverse number. Let's write that. (8/5), and that gives me this system of equations. So now I have zeros over here and I have ones in the diagonal. Now I need to provide 0 here and here and here, and I'll do that by working my way back, multiplying the third equation by some number, subtracting or adding to the second equation, and so on. So in order to provide a 0 here, I want to multiply by 3/8 and then subtract the result from the second equation. And that will give me this system of equations. And as you can already see now, we can already see that x3 equals 5 and x2 equals -2. So what we have left now is to eliminate this number. In other words, make it a 0 and make this a 0. So I'll have to multiply my third equation by 1/2 and then subtract it from the first equation. And the result is this. I obtain my 0 here, and I multiply 1/2 by 5. That's 5/2, which I subtract from the 7/2. That gives me 1. And now I need to finally subtract the second equation from the first, because I have a 1 here and I have the 1 here that I want to eliminate. And when I do that, I get this system of equations. So now I can directly read off that x1 is 3, x2 is -2, and x3 is 5. We should remind ourselves that there's an invisible x1, x2 here, and x3. In fact, there's an x2 here as well, but I don't need to write it because 0 times x2 is just 0. So we won't write that. This form of the equations that I've reduced or simplified into is actually called reduced row echelon form. That is, this form with all zeros and ones in the diagonal. That's called reduced row echelon form. Well, that's it for now.